Thank you for joining us today. My name's Brad Hines and I work at CSIRO at Armidale. And today I'll be talking to you about our resilience project. So the resilience project is an AWI, it's an add-on project to the MLP. It's co-funded by CSIRO and AWI and utilises the really good resource that is the MLP progeny. So I'll just start by talking about defining what resilience is, and there's a lot of definitions out there in industry about what resilience really is. But we describe resilience as an animal's ability to cope with challenges they face in their environment and return to being productive again. So animals in our production systems face a whole range of environmental challenges every day, and they include a lot of things, not limited to the list here, but include things like climatic extremes. So we're talking about heat and cold stress, management-induced stress, pathogens that they encounter in their environment, and also because sheep are flock animals, social disruption is another challenge that they face. They do struggle with being mixed with unfamiliar animals. So the important thing is that animals respond to these various challenges with a series of what we call host defence reactions, and they can be physiological in nature, immunological in nature, or behavioural in nature. And all of these different host defence responses in the animal are what actually lead to an animal being resilient. So these various defence mechanisms are all highly integrated with each other, and so each one influences the other. So what were the key aims of the resilience project? So we set out initially to develop and validate methodologies to assess resilience in merino sheep. So before we can develop genetic strategies aimed at selecting for specific traits, we obviously need to be able to measure those traits in the animals first. So it was really important for us to come up with methodologies that were practical to apply on farm and that can be applied on large numbers of animals so that we can get an accurate picture of the genetic parameters around these traits. What we wanted to work towards in this project was to get towards conducting a cost-benefit analysis around selecting for resilience. And what's really important here is to look at what are the costs to a producer in collecting that extra data to identify resilient animals in their herd versus the benefit that's achieved by selecting for resilience. So that's a really important thing that we need to do as we move forward with this work. And the ultimate aim of this work long term is to work towards developing an index which can describe an animal's genetic potential to be resilient. And we've termed that Residex at the moment, and you can think of this along the lines of the Merino Productivity Index that we use to look at productivity. We'd like to work towards developing an index that looks at resilience. So Residex, what is it about? It's about breeding for management efficiency and improved welfare in animals. So we all know that a big part of the cost of running animals is the labour component to manage those animals. And this is about making the management of these animals more efficient and at the same time improving the health and welfare of those animals. So we know that consumers are increasingly concerned about the welfare of the animals that are producing their food or fibre that they use. And so it's really important as an industry that we work towards maintaining consumer confidence in the products that the sheep industry have to offer. So if we go back to the previous slide where we looked at all of those different components that contribute to resilience, we'll just specifically talk to you more today about the immune side, so the strength of an animal's immune system and how that relates to its ability to resist disease as an important component of that resilience index. So really the take-home message for you today is that selecting for productivity is not selecting for resilience. So it's really easy to make the assumption that if I select those animals that are most productive in my production system, that they've got there by being the most resilient animals. But we know that that's not the case, and there's lots of evidence out there in the literature now from all kinds of domesticated species, pigs, chickens, cattle, and sheep also, that if you select really hard for productivity, that you can impact on an animal's resilience. And to use an example with our immune immune work, where we're looking at the strength of an animal's immune system, ability to resist disease, we know that if you select hard for productivity, that you will increase susceptibility to disease in those populations. So immune competence, what are we talking about when we talk about immune competence? So immune competence is really describing the ability of an animal to mount an immune response when challenged with a pathogen. The immune competence phenotype we've developed, or the measures we use to look at the immune competence of animals, what we've specifically targeted with this work is to look at the ability of animals to respond to a challenge when they're under stress. And the reason we do that is because we know that in industry, we get spikes in the incidence of disease at those times when animals are undergoing stress. So it was really important for us when we were developing the methodology that we looked at identifying animals that can cope with a challenge when they're under stress. And so there's a little quote here which I think sums up our approach pretty well, and that is that the best immune system is not necessarily the strongest one, but rather the one that maximises fitness in light of constraints. And what that's trying to say is we're not targeting animals with the strongest immune system, it's the animals that have the best ability to mount an immune response when they're under stress. So just to give you a little bit of an idea of the variation that exists in the population, obviously if we're targeting genetic improvement of any particular trait, it's important that there is some variation in the population to start with to allow us to select for that. So here's just a simple series of graphs which shows the sires that were used in to generate the 2017 drop progeny, and again the sires used to generate the 2018 drop progeny. We've tested those progeny, and these are the immune competence averages, if you like, for their progeny. So you'll see that there was 15 sires used in each year. As Jen's mentioned in earlier slides, there are a couple of link sires that connect the years, but we won't worry about that here. But what I'm really trying to demonstrate with these graphs is that there is variation, significant sire effects here, and that the immune competence of all animals is not the same, that there's variation there and we can select for it. So it was really important for us when we're looking at the immune competence trait to learn something about if we go down the track of selecting for immune competence, what will the impacts be on other economically important traits? We know from the literature that if we select for productivity that we do see some increase in susceptibility to disease. So we set out to look at associations between immune competence and growth and carcass in the animals that we tested. So you'll remember back to Jen's earlier talk that with the Wethers that we've immune competence tested in this project, that some of them have been retained here on site to collect lifetime measurements, while a portion of the progeny was sent to slaughter as lambs. So they went through the feedlot and then on to slaughter as lambs at a commercial abattoir. So if we just concentrate on the table on the left, we're talking about the Wethers that were retained. So these were retained as wool growers here on site. And we can see on the left we've got birth weight, weaning weight, yearling weight and condition score. And then we're looking at carcass traits for the live animals. So we've got fat, eye muscle depth post-weaning, and fat and eye muscle depth as hoggets. You'll see the numbers on the screen there. These are relating to genetic correlations. And whether you get a green smiley face means that those correlations are favourable. If you get a red frowny face, that means that those correlations are unfavourable. So on the right hand side, we're presenting similar information, but this is on the slaughter Wethers. So we're looking at the growth in these animals. So we measured average daily gain at the feedlot. The next trait there is feedlot exit weight. And we looked at carcass characteristics, including the hot carcass weight and the yield. So you'll see from these tables that we do see a weak genetic correlation that's unfavourable between immune competence and growth. So that was no surprise to us. We expected that. And that reinforces the message to producers that if you select hard for productivity, you are actually increasing susceptibility to disease. So we also looked at associations between immune competence and various fleece traits. This is obviously in those retained animals that have been kept on site. The good news here, we have lots of green smiley faces and not too many frowny faces. So we saw positive or favourable correlations with things like greasy fleece weight and clean fleece weight. Yield was an unfavourable relationship, but again, it's weak. The next traits on the list are fibre diameter. Then we have the traits that relate to variation in fibre diameter. So we're looking at standard deviation, coefficient of variation, staple length, staple strength, and curvature. So generally we saw favourable correlations here, but with yield we saw an unfavourable correlation. So this was the bit that was of real interest to us, and this table tells us about associations between immune competence and the health outcomes we see in these animals. And it's critical, if we are to select for immune competence, that we have some confidence that that measure translates into favourable health outcomes for those animals during their life. So on the left we have breech strike on the table, post-weaning weck, hogget weck, yearling fleece rot, we have post-weaning dag, and the two bottom traits there relate to fitness compromise. And if you listened to Jen's talk earlier, Jen talked a lot about how she formed an index that identifies fitness compromises to animals. So the first one essentially captures all of those disease-related fitness compromises to yearling age. The bottom one in the table relates to all fitness compromises. So that includes disease-related compromises and other compromises. So the really encouraging thing here for us was that we got quite a few smiley faces here, which means that our measure of immune competence has some ability to predict favourable health outcomes in this animal. And that was really the target of what we wanted to achieve. The fleece rot was the only one we had an unfavourable correlation, but we had very limited fleece rot data over these years because of the seasonal conditions. So this was really encouraging for us. We acknowledge that these estimates have large errors associated with them, and as we look at more and more animals, we'll be able to reduce the errors associated with these estimates and have more and more confidence in the results that we are seeing moving forward. So it's important to consider that when we've got this negative correlation, although it's weak, between, for instance, growth and immune competence, are there animals in the population that have a strong immune system and are also productive? It's really important for us to look at that. So what we've plotted here is on the bottom axis for the sires used over those 2 years of the project. We've plotted their immune competence score, if you like, on the bottom axis. So as you move to the right, their immune competence is getting better. They've got a stronger immune system. And on the left axis, we have the Merino Productivity Plus index value for those animals, and that is a within flock index value. So as you go up, these animals are predicted to have increasing productivity. So the really encouraging thing for us was that we get a nice scatter here showing that there are animals in the population that have both got a really strong immune system and are expected to be able to resist disease and are also highly productive. So those animals in that red oval, they're the animals we would be targeting if we're driving those two traits together. So where do we want to end up? As I mentioned, we're interested in developing or working towards developing a type of resilience index that producers can use to target improve resilience in their flocks through selection. So some of you may have seen some of the recent stuff coming out around Immundex, and that's some work we've been doing with Angus Australia in Angus cattle, and we've got to the point there where we've developed a breeding value for immune competence in Angus cattle that producers can start to use to place selection pressure on this trait. So where we would like to get to is to come up with a similar sort of index for merino sheep that producers can use in a similar way to drive improvements in resilience in their flocks. So that's about all from me, but I would like to acknowledge the enormous team that works on these projects. I get a pretty easy ride, to be honest. I don't do a lot of the grunt work, so I can't claim that. So I'd just like to run through some acknowledgements. Obviously, we'd like to acknowledge AWI who co-fund the work. We couldn't do this work without support from industry funding bodies like AWI, so a big thanks to them. Like to thank Dr. Sue Mortimer at New South Wales DPI, the lambs in this project, once they go to slaughter at Fletcher's, they actually enter into an MLA funded project that Sue runs, where they're looking at carcass characteristics in these animals and also eating quality. So we'll be able to give you more of a snapshot of that down the track as that information filters in, so we can start to look at relationships with our resilience traits there. We've also done this resilience work across a couple of sites. So we've done some work at the Trangie site as well, and we'd like to thank the technical staff there. A big thanks to the QA team at Fletcher's International, where we slaughter the lambs. They've been terrific in providing assistance to collect all that offal data that Jen talked about earlier, and that data is included in the illness indexes or the fitness compromise indexes we've looked at today. Bob Hickey at Protein Plus Feedlot up at Gundawindi. Bob runs a really smick show up there and has allowed us to put our animals in that commercial feedlot and monitor their performance. So a big thanks to Bob. The rest of the names on that slide are the technical staff from CSIRO that have worked on this project, and a big thanks to all of those guys. So thank you.